Alright, in this video I'm going to discuss division. I'm going to define what it is and clear up some things that might be confusing. I'm only going to talk about division with regards to natural numbers. Okay, I'm going to talk about different ways of expressing division problems, talk about remainders, talk about how to divide large natural numbers, all right, and how to test to see if certain numbers are divisible by other numbers. All right, so first of all, what do we mean by division? All right, the problem you're trying to solve is similar to the following. Imagine that you had a certain amount of money and you had to share it with a bunch of people. Maybe you ran a lemonade stand. Okay, let's say you ran a lemonade stand and you made $10. So you have 10 $1 bills. Okay, and let's say you and 4 of your friends, so 5 buddies, were the ones that worked really hard to make the lemonade stand. So everybody's going to get an equal amount of money. How much should we give each person? All right, now without fancy math, you might be able to see, just with thinking about it, you might be able to see that each person gets $2, right? If each of the 5 people got $2, that's where it would take $10 to share, give each person that much. All right. So this is what comes up. This is what you need to be able to do when you have a division problem. Now, I wrote that with lots of words. If you wanted to write it using nice compact math notation, you would write this like this. You would say 10 divided by 5 is equal to what? So that there's like a potential homework problem. Okay, and I have a slash there. All right, that's a common way to ask a division problem. Another common way is with this other symbol, a line with a dot above and below. Okay, so that's the same question. It's asking if I divide $10 between 5 people. All right, so we can do a couple of examples of that, and let's see if you could knock these out just by thinking about them. So what would the answer to the following be? All right, take a second to try to do these now. Okay, so I'll go ahead and do these. So $4, again, think of the lemonade stand if you like. There's no reason why you can't do that. No reason to make it complicated. So if I had $4 split between 2 people, they each get $2. $4 split between 4 people, they each get $1. And you know what? The last one is the same. I'm sorry, I meant to do this. What if I did that? What would the answer be? So that would be $4 split between just yourself. Well, that means you get the entire $4, right? All right, very good. Now, what about if I had 2 people and I was trying to, or $2, and I was trying to split it between 4 people? Okay, that is not going to give. That's not going to give this answer. Okay, so the reason that I brought this up is that you can't switch the order. Okay, $4 divided up between 2 people is not going to be the same as $2 divided up between 4 people. So this means that division, unlike multiplication and addition, is non-commutative. Remember that word? So that's just a fancy way of saying that the order matters. Also, it's non-associative. So if you had a chain of several division, something divided by something else, divided by something else, the order that you did it would matter. Okay, so keep that in mind. So don't don't get too comfortable changing the order around. All right. So I hope those simple examples are clear. Now let's go on to another issue that might come up. Suppose that we had $7 and we're going to divide it between 3 people. Okay? Now they would each get $2. Okay, they'd at least get $2, but I'm sure you would agree, if you could imagine working this out, try to take 7 ones and try to make 3 equal piles. You will see that you're going to have an extra dollar left over. Okay, so this sometimes happens. You can't always divide money equally between people, $1 bills. So we say that there's a remainder. So 2 remainder 1. Remainder, left over. Okay, so sometimes you will have remainders, and we need to deal with that. So let me now give you some division problems. Here, I'll do one more with the remainder, and then I'd like you to do a few. Let's say I had $8 divided by 5 people. Okay, they would each get a buck at least, and then you'd have 3 left over to deal with. So 1 remainder 3. All right, so let me now give you a few to try. All right, see if you can do these in the next few seconds. You can stop the video again always if necessary. Okay, and I'll go ahead and do these now. So the first one, 2 remainder 2. The next one, 2 remainder 1. The next one, 3 remainder 2. Okay. Another fun fact that you need to be thinking of. Okay. What would you think it would mean if you had this situation? What if we had some amount, like $5, and somebody asked us to divide it by 0? Okay, now we could make guesses about what it means. Let's see. So that means you have a bunch of money and you have to divide it between nobody. So maybe that means nobody gets no money. So maybe the answer is 0. Okay. On the other hand, maybe there's no money wasted, so maybe we didn't spend any, so maybe you think the answer is 5 because we have 5 left over. The point is, the bottom line is that there's no real clear way to understand division by 0. Okay, and we don't try to make something up that makes sense. People haven't really agreed on anything that makes sense. They haven't agreed on a useful definition, so we literally don't allow this in math. Okay, so this is, we say it's undefined. We haven't said what it is, so we can't do a math problem that has this. Okay, so another way to say the same thing is it's not allowed. You will never, ever, ever, even in college, you will never have a math problem. You'll never have a situation where you're dividing by 0. If you do, if you find yourself doing that, you can bet there's a mistake and you're going to have to go back and change something. Okay? So you simply cannot divide by 0. Please remember that. All right? Now, you can do these small division problems in your head. What about if you've got real big, ugly problems, numbers, like what is 112 divided by 21? All right? Now, that one you might even be able to kind of do that one in your head, but if you thought that was doable, how about 3,456,129 divided by 1,987? So eventually everyone's going to say uncle. Okay, it's just going to get too painfully tedious to work this out. Okay, now in the real world people would just use a computer, but if you didn't have a computer handy, let me show you how you would attack any division problem. Okay, that was getting a little painful. So what you can do is put the first number underneath, what's traditionally done is you put it underneath two line segments joined like I've drawn here in red, and then you put the 21, the other number, the right number there to the left of the first number. Okay, and then you can start to do the subtractions, you can start to find the answer in pieces. So I would ask myself, how many times does 21 divide 112? Well, it can go at least 5. It can't go 6, but it can go at least 5. So then I would multiply 21 by 5, and that gives me 105. And so I have 7 left over. So the answer is 7 remainder 7. Okay, that was a quick and easy example. Let me do one that might go on for a couple more stages. What if I had 3 divided by 2,487? Okay, so you would do it again in pieces. Now, I'm not going through the entire recipe. I'm assuming that you've seen this before, and I'm just kind of giving you just enough to spark your memory so you can recall this from hopefully a previous experience. So 3 goes into 2 0 times, so you still have 2 left over when you subtract the 0. Then you can bring down the 4, and now you ask yourself, how many times does 3 go into 24? Well, it goes in 8 times. So now I have 0 left over, but I have to keep dropping all the rest of the numbers one by one. I'll drop the 8. How many times does 3 go into 8? Well, it goes in 2 times, and so let's put a 2 there, and we'll subtract and see what's left over. 2. Now I drop the 7. So for 2,487 divided by 3, the answer is 829. All right. And then once I multiply by 3 times 9 and subtract, I have a 0. Okay, so the remainder is 0. If I would have had, let's say, a remainder of 1 or 2, then the answer would have been 829, remainder 1 or remainder 2. All right. Now, will you have a remainder? Is there an easy way to find out if you have a remainder? For division by some digits, there is some quick and easy ways to see. All right. So, for example, numbers are divisible by 2 if they are even. Look at the last number. Okay, let me show you what I mean by that. So, is the following going to have a remainder? 9,783 divided by 2. Okay? And by the way, when I say divisible by something, it's divisible means that there's no remainder. Okay? So is this blue problem going to have a remainder? The answer is yes, because this is an odd number. Okay? How can you tell if a large number is odd very quickly or even? Look at the rightmost digit. That's all you have to look at. So 3 is odd, so therefore the whole number is odd, so therefore there will be a remainder. Okay? Now, this numbers are divisible by 3 if the sum of all the digits is divisible by 3. All right, let me show you what I mean by that. Okay, so for example, looking at the last problem I just did, let's say that we had 9,783 divided by 3. Okay, is it divisible by 3? Okay, now don't just because the first number ends in 3, that's not a guarantee. So get that idea out of your head if that occurred to you. Okay, instead what you need to do is think about the sum 9 plus 7 plus 8 plus 3. Okay, that is, what is that? 15, let's see, 16 plus 11, so 27, right? 27, is that divisible by 3? Yes, it is. 27 divided by 3 is 9 without a remainder. So therefore, because the sum of the digits is divisible by 3, then this is also divisible by 3. So this has no remainder. So I was able to figure that out without having to do all the work. Okay? So though you might want to remember these little quick ways. Some other nice ways, and I'm not going to give you one for every number. Some of them are not so easy to remember. Numbers are divisible by 5 if they end in 0 or 5. You may remember when you were younger, you may remember learning to skip count 5, 10, 15, 20, 25, 30, 35, 40, and on and on. Notice that all the numbers when you skip counted ended in either 0 or 5. Okay, so that also has to be true for big numbers. Okay, and then numbers are divisible by 6 if they are divisible by 2 and 3. So I just gave you a trick for 2 and I gave you a trick for 3. All right, if both of those tricks work for a number, then it's divisible by 6. Isn't that cool? And then the last one I'll give you, numbers, oh no, I'll give you 2 more. This one's like the 3. Numbers are divisible by 9 if the sums of the digits are divisible by 9. Alright, so think about numbers that you can divide by 9 without a remainder. 81, 900, right? 270. Okay, you'll note, write down a bunch of numbers. You'll notice that if you add the digits, they always add up to a number divisible by 9. Okay, and then the last one I'll do, numbers are divisible by 10 if they end in 0. Okay, think about skip counting by 0 and you'll see that you always get a number that ends in 0.